In part 1 of the Krakatoa Stand-alone Renderer intro, we saw how splines out of 3ds Max can be exported to Krakatoa SR and rendered the same, producing exactly the same result as PAT here rendered inside of Krakatoa MX. But as mentioned already, if the modifier stack of the PAT here has some modifiers, for example, let's say we enable the magma flow that is defining the density and color as seen in the earlier videos about Krakatoa MX here. Rendering just the splines wouldn't cut it because we would lose all the color information provided per particle inside of 3ds Max. Let's take a look at what happens if we select export to Krakatoa SR and hit the export frame button again. This time the export is going to take a little bit longer because the particles will have to be written out to a PAT file which bakes all the information about density fall off, color, any deformations that might be added to the stack and so on. Once the 3.2 million particles are saved out, the scene will launch and will render, and the result should be identical to the rendered image produced by Krakatoa MX. Let's also render the frame in Krakatoa MX in order to have a reference. This is what it looks like in Krakatoa MX. Let's right click and say we'll load in the RAM player the result from Krakatoa SR in channel A, and once again in channel B we'll put the rendering from Krakatoa MX, and we can once again compare and see that they are identical. Obviously the saving time of the scene was longer because all the data had to be exported. If we take a look once again at the output, there is a new subfolder called PAT. This contains 80 megabytes of particle data. These are all the particles that would be generated normally to represent the 3.2 million particles that end up in the final frame. In addition to baking all the particles out, Krakatoa MX can also export any matte objects to Krakatoa SR using the OBJ file format. Let's select the teapot that is inside the particle system and make sure that it is defined as a matte object. Right now there is, if we deselect it and press the select highlighted, we should get the teapot selected again because currently it's added to the Krakatoa matte object selection set, and if we would render inside of 3ds Max we would see that the particles behind the teapot are occluded. Let's now export to Krakatoa SR. Obviously this will once again export all the particles and also the OBJ file, which is the matte object. And once the export has finished, we're going to render in Krakatoa SR and then compare to the image rendered in Krakatoa MX without the matte object in order to see the difference. Now you're going to see that in addition to the PAT here definition, which was written to a PAT file before, there is also one matte object, the teapot, which was written to teapot 001 underscore matte 0000. This is the frame number. And if we would look once again at the output folder, we're going to see also a new matte subfolder which contains all the matte objects. Let's take a look at the result. Once again we open the RAM player. The RAM player this time will contain the rendering out of Krakatoa SR, including the matte object. And since we haven't rendered in MX with matte objects on, let's load the previous frame and take a look. Now you're going to see where the matte object is occluding particles that previously were visible behind the teapot. Now they're not. Now let's see what happens if we export not the PRT here, which is a procedural object inside of 3ds Max, but an actual PRT loader that references an external stream of particles. We're going to hide the PRT here because hidden objects are not being exported anyway, and we'll keep the teapot in the scene because it's used as a matte object. Now we can hold Shift and press PRT in order to create a new PRT loader, and we'll pick the file that we exported previously when we were baking the PRT here to PRT for the previous rendering. Now in the scene we see 1% in the viewport of all the particles, switching to 10%. Looks a little bit more like the preview that we had before, but this is still 1/10 of all the particles of the 3.2 million particles that are in the file. Let's switch back to 1% and try to export this scene to render in Krakatoa SR. This time the export is much faster because we're using an external reference of an existing file, and the absolute path to this file is going to be included in the loading, and no reloading and resaving of particles within Krakatoa MX during the export has to occur. The result will be exactly the same. We can go and take a look in the frame buffer. The result of the rendering is exactly the same as in the previous attempt, but this time the export time out of 3ds Max was much faster. Obviously, if we select that PRT loader and apply some deformation to it, for example, we grab bend modifier and bend the particles around, exporting now would actually require a new saving of a new PRT file. If we hit the export frame, the matte object is first being exported, and then after that a new PRT file will have to be written. The new PRT file will have a name PRT loader 001, and it will represent the particle saved from the previous PRT here, but with the deformations already applied on top. After the 3.2 million deformed particles have been exported, the frame will render. We can take a look. In this case, the points file is a new file called PRT loader 001, and if we take a look at the rendered frame, it will contain the bends here, and we can also see the matte object inside. This shows that the exporter inside of Krakatoa MX, which is writing the Krakatoa SR output, takes care of figuring out when it can reuse the data in order to simplify the export and reduce the data amount, and when there are modifiers on the stack or materials containing textures which would require baking of particles, it automatically bakes a new PRT file and passes it to the standalone renderer.